Sound design.
All right, so in the last video, we imported some GLL files into 3 different audio analyzers. And in this video, I want to take a look at how to start playing with them, how to start trying to get familiar with them so that when we get in the field tomorrow and we have to use this equipment that maybe we've never used before, we can be a little bit more prepared. Okay, so starting in Smart, you can see that I have these 2 speakers imported. I can change the level offsets here just by clicking with my mouse and dragging around. And that could be interesting just to see, like, you know, when I do this kind of combination tomorrow where I've got this main and this sub, like what do I expect to see here? And just sort of studying these responses. And depending on the magnitude relationship, what is the crossover? What's the crossover region going to be? So if I do something that's a little bit more offset, I'm having trouble clicking on this. So if I do a big haystack like this, okay, now my crossover region is over in this area, right? Let's grab a square. So now I've got something more like this for my crossover region, right? And that's going to come down here. And so I should be looking at this area. But if I just shift click and sort of put these together, now my crossover region is going to be somewhere like over here. And so now I should be, you know, looking down here at the phase relationship in this area. Okay, so that's a little bit of investigation we can do in Smart, but if we want to start actually changing these things and maybe inserting some filters and playing with this alignment, we can hop over to Room EQ Wizards. You can see I've got the exact same data here, and I can do trace offset, but I can also start playing with the alignment and the EQ. So what should we look at first? Well, one thing we definitely need to do first before we start playing with the alignment is the timing. But let's look at EQ first because that's a little bit easier. So these measurements that I've imported here are of solo elements. So this is an HDL20A solo by itself, but with the settings I expect to use on my show tomorrow, and the same thing with this sub, this 8006. That might not be as interesting to EQ as something that is going to be more like an array. So this guy is another GLL that I exported where I set up my array with 8 different elements, and I actually put in the display angles and I measured at a distance where I expected. And this still doesn't have any room interaction because it should be an anechoic response, but now I can at least see some element to element interaction and see, you know, we see some of this low mid buildup here because all of the elements are together. And we see some of this stuff happening up here. So this might be more interesting to play with in terms of EQ. And the way we can do that in Room EQ Wizard is just by selecting that trace, clicking on the EQ window, and that brings this up. And if you're wondering why my target looks like this, it's because over in the preferences, I have imported my own house curve. You can get exactly this house curve, and I'll put a link in the comments of this video about where you can get that. So all you need to do in this EQ Wizard, not EQ Wizard, in Room EQ Wizard in this EQ window is I think this defaults to speaker driver, and we don't want that. We want full range speaker, and I think I basically have, you know, pretty much everything turned off here. So that's all kind of disabled. And I think I just clicked calculate target level from response, and that put it in a pretty good place. And now I can look at, you know, comparing the response of this array to my target, and now just practice doing some EQ shapes, practice doing complementary EQ. So in this window now I can click on EQ filters, and now I can just do a little bit of practicing. So I might say, okay, what if I get into the field tomorrow and I make this measurement and I actually see this here and I'm listening to it, I'm thinking, yeah, I might want to try and put a filter there. So what is it going to take to get a complementary EQ filter there that matches this shape? Well, I can just see from my cursor that this is at 516 Hertz. And if I wanted to, I could, click and measure this, but I'm just going to try popping in a filter because what I want to get better at is just kind of looking at the display and knowing as quickly as possible what EQ parameters I need to make this shape. So I need to set this to manual, peak filter. I think I said 518. I'll try -6 to start with. That's a little too high and it's too narrow. So I'm seeing the predicted response here in this lime green color. So I'll turn this down to, let's say, -5 or -4, and this something to be more like Q of 5. That's a little too wide. That's getting better. And now I can just keep playing with these. And as I'm going through and practicing, I can try and get faster and faster with this instead of just guessing and waiting to see what the result is. Okay, and now I might go down here and say, what would it take to put a filter here? And what would it take? These look really narrow. I don't know if I would actually EQ these in the field, but again, this is not a real life response because it has nothing, there's no room interaction, but it can just be a good place to practice putting these filters in. And then if I get tired of this and I just want to play around, I'll click match response to target, have Room EQ Wizard, run its optimization routines, and then look at what filters it puts in. Oh, okay, maybe this would also be a good type of training where I can see the exact parameters I would need for this particular filter and that particular filter. And I'll just point out to you that it has the numbers of the filters up here at the top. So if you're wondering like, wait, which one is this? Okay, that's number 4. So I can turn number 4 off and on and look at its parameters. Okay, so that's one thing I can do to just help my training, practice doing this kind of EQ. So I'll close this and I'll hide this. So another thing I might want to do is look at the alignment between these two things and maybe even create some pre-alignment values so that when I get in the field tomorrow, all I have to do is take like a laser distance measurement from my alignment position, and then I can quickly have a solution for the alignment instead of needing to wait till I get out my audio analyzer and then, who knows what sort of like challenges I'll run into. But I'll immediately have an answer if I already have my pre-alignment values ready to go. So let's look at how to do that. There's a cool new tool here in Room EQ Wizard called Alignment Tool. But before we do that, there's something we need to take care of, and that is a little problem. So you may remember that when I exported these tables from the GLL viewer, they did not create the transfer function at the exact same delay value. And I wrote that value into the file name so I wouldn't forget. And so I know the text is really tiny here. You can see this one on my main speaker is 29 milliseconds, and this one on my sub is 27 milliseconds. And I've already put those into a little text document here so I can see that the difference between them is 2 milliseconds. And I want to take a quick sidebar about this because delay locator values are something that I have had a tough time wrapping my head around. So let's look at a quick experiment in Map 3D. So in Map 3D, I just have a speaker here and I've got a measurement microphone here. And in the processor settings, I have 0, everything's flat. And in the measurement, I have almost a perfectly flat measurement. This is a magical speaker where everything's perfectly flat. And the only reason that this is down a little bit here is because that's as close as I could get it to being flat with this. I wanted to use the exact same delay locator values. You see I have here 29.17 and over here I have 29.18. And so now what I want to show you is what would happen if the delay locator was off by this amount. So 27.1339. 27.1339. So this would be the difference. And just to make this a little bit more clear, this would be like if I was in my audio analyzer and I took this first measurement of my main And then I change the delay locator, which would be right here, right? So let's say that I took this one at 0, and then I changed this and now measured my sub. And as you guys know, changing the delay locator in between these two measurements is a big no-no if we want to compare our relative phase values. Okay, so back over here in Map3D, what I'm trying to show you is that for me, I don't know if you'll have the same problem, but for me, intuitively, I see that we have a difference of 2 milliseconds, right? Like, I already noticed that. I subtracted these two values. Okay, we have a difference of 2 milliseconds. And for me, I see, oh, 27, I need to go up to 29. So I can just put in 2 milliseconds of delay in my processor, right? And that'll fix it. Oh, but it doesn't. It makes it worse. I went in the wrong direction. And the thing that I have such a challenge understanding is that this is not about my microphone input. This is about the reference input. So everything is backwards. And it's the exact same way over here in RumiQ Wizard. So let me get to that in a second, but first let's fix this. So over here in my processor, this is not where I fix this. I really need to fix it on the delay locator. So you'll see that when I change this back to 29, and it needs to be exact, right? So what was my original value? 29.1715. 29.1715. There it goes. Perfectly flat again, right? So this is where this I hope that helps a little bit. This helps me just playing around with this in Map3D to see how this all works. Okay, so to make these two aligned as though they had the exact same delay locator values when they were measured, I'm going to just go into the SPL in phase tab of the sub. So I want to make this one match up with this one. This one is 29 milliseconds. This one is 27. I'm going to open up this offset T. And before I change anything, I want to show you this overlay screen. Okay, so we're way zoomed in here. And just to give you a point of reference back here in Smart, this is what this looks like. So you can see these two tracking together, and then they start to deviate. So we have the exact same thing over here in RumiQ Wizard. You can see them kind of tracking together down through here, and then they start to deviate up here. Just the graph looks a little bit different. And I wanted to show you that before we start to change our timing reference here. And this is where two monitors would come in handy. But just try to keep this picture in your mind here. So remember what I did over in Map3D? I actually had to add delay to the delay locator. And so that's what I'm going to do in RumiQ Wizard. So I'm going to grab this value and I'll add it to my sub. Okay, and just notice, look, I'm adding delay and you're expecting the phase trace to tilt down, but instead it went up. It's backwards, remember, because we're actually messing around with the reference here. Okay, so that's done. So I'm going to apply and close. Now the values have changed and now these two should be aligned. And you see they've actually gone farther apart. Okay, so our alignment is actually worse now that they are taken with the same delay locator values, but even more reason for us to, work on creating our pre-alignment values. Okay, so we have taken care of that little offset problem, and now this should be more like how it's going to happen in the field tomorrow when I take my measurements. Let's first take care of this offset. We've got this big hump here. I don't know if this is exactly how I want to do it in the field tomorrow, but probably not this big of a hump. So let's do measurement actions. We'll click on our sub and let's try taking away 10. That's too much. How about 6? Okay, let's try that. So we'll add offset to delay. So we're actually changing the data. I'm going to zoom in here a little bit. And I'm going to zoom in here a little bit. Okay, so now we've got a crossover region in this area here. And now I can switch over to using the alignment tool. This is where we were trying to get to the whole time, but we had to set things up properly, right? So to make this work, I need to choose my main speaker and then my sub. And now this black trace shows the result if you sum these two together. So right now we are not doing too well. So if we were to just use our laser distance measure in the field, just with a geometric distance offset, this is the result that we would get, okay? This is why we need to take the time to figure out these pre-alignment values if we want to use just the geometric distance offset in the field. Okay, so we can start playing around with this. So we need to put the cursor somewhere in the crossover region to start taking action on this. The first step might be level phase at cursor. Now this is purely cosmetic, just for our eyes, to make it a little bit easier to read this. And you see it tries to flatten out the phase. I know this graph is a little bit messy. I wish there were a way to turn off this black trace sometimes. I can turn off, no, you can't. As far as I know, you can't turn off anything down here. And so you can keep sort of clicking around and click level at cursor until you find a place that makes it easier to read. And so I'm going to do that a little bit. Okay, so I like this, or do I like nothing? So if I click reset all, so now that I have it set up, I can start playing around with the gain, delay, and polarity and see if I can find a good pre-alignment value. So I could just grab this delay guy and I can start dragging him around, and I can see that the green trace down here, I'm looking down here in this area, the green trace is getting closer to this red trace. And as it does, this black trace starts to improve. And I'm going to zoom in on this y-axis a little bit more. Okay, so I'm just sort of playing around here, and I can quickly look at a few different variations. You can just sort of drag this cursor around, right? I'm just dragging it around really fast and watching that black trace. So this is not good, right? And this is not good. But as I drag it slowly, I just sort of watch it improve. And so that's one way to do it. Another way would be to pick a frequency, let's say this guy right in the middle here, and now try to make everything match right there. And I can do that with these buttons over here as well. So align phase slopes at cursor is not going to align these two guys in time, but it will try to make the slopes match in an area around the cursor. And I don't like that result very much, or that result very much. So it doesn't always do this great, which is why sometimes it can be faster just to sort of put this in manually. So now that I have one frequency matched here, I might want to click Align Sum, and that's going to create a copy of the result here. And now I can go through and try a bunch of different variations. So I found one that works with polarity normal. I might want to find one that works with polarity inverted, and something like this, right? And as I'm looking at the black trace here, I can see that it's slightly better than the one I just did, this blue guy. Okay, aligned sum. Okay, and I can keep playing around with this until I've built up a few different variations, and then I can decide which one I like better. And the great thing about RumiQ Wizard is that it keeps track of all these settings. So you can see here in this little text, it says B was delayed by this amount, and there's a polarity inversion. And in this one, it says B was delayed by 5.3 milliseconds. So what's interesting is to see what Subaligner has to say. So over in Subaligner, if I put in the same details, I've got my RCF speaker. This is the setting I've been playing with. And I put in my sub, and I just put in matching distances so that the distance will basically cancel out, because I just want to see the pre-alignment values. And so Subaligner recommends delaying the sub by 9.97 milliseconds and a polarity inversion. So that's kind of what we were looking at here. So this is what we were getting close to. So if I put in Subaligner's recommendations, here it is. And I can also click Align Sum on that one. And then when I close this, I'll have all of these results left over. And if I want to get really picky, I can zoom way in. And now I can decide which one I like the best. And then I can look at those settings, and then I'll have my pre-alignment values for setting up the show tomorrow. Now, going back to this alignment tool for just a second, you may wonder, could this alignment be further improved? Yes, we're trying some delay and we're trying some polarity, but two things. Number one, this seems like a lot of delay, right? 10 milliseconds? That's quite a bit of delay. And also, I wonder if this could be improved to help us get even more summation. So at this point, I'm getting really picky, but you know, this is the research phase, right? This is the time to play around and sort of learn about these things. Okay, so over here in this overlays window, I have clicked Unwrap Phase. And now this can make it a little bit easier to start investigating what's going on here. And I know from some of the research that I've done before that when I'm looking for possibilities of adding filters to change the phase, to add phase shift, to maybe improve the alignment, I know I'm sort of looking for multiples of 45 degrees. This is kind of the pattern I'm trying to train myself to see. So what I'm going to do is I'm going to create a 45 degree little visual aid. So here's 45 degrees. And I can move this guy around. And there's nothing in here that's really 45 degrees. Okay, so let's try 90 degrees. Let's try this guy. Okay, this is starting to make a little bit more sense. So check this out. So around this area, this might work, like around 60, maybe 70. If I put in a filter, a second order filter that will create 90 degrees of phase shift on the sub, that might improve this alignment. Okay, so I could do this in Room EQ Wizard by just clicking on this trace here, clicking on my sub trace. I go to EQ, I go to my EQ filters, and you can see I've already been playing around with it here. You can insert a crossover filter. So this is where I would put my, second order low pass filter, and I might try 70 Hertz, and then I could insert that and go back over to predicted phase and look at the result. But instead of doing it here, I'm actually going to open another app that I've been playing with called Crosslite. Now, Crosslite's actually been around for 10 years. It's from Brazil, but I only recently got introduced to it. And I'm not showing it to you to say that you need a new tool, but it's just something new I've been playing with, and I think it'll actually be a little bit quicker to show you some of the results here. Okay, so this is the exact same data that we had before. I've got my main and sub here. And the first thing I'm going to do is put in the same level offset I had before. And there are some optimized functions here in Crosslite, so I can match these levels automatically. And I can also match time. In this case, it doesn't work very well. It pushes this way over here. And if we actually look at the phase, it's kind of all screwed up now. And you can see that it added 250 milliseconds. You guys know automatic optimizers don't always work, especially in this case when I'm just getting very smooth data from a GLL file. So I can't expect too much. So I'll reset this, and I'm going to drag my little cursor back over here. And this is sort of like changing the delay locator, but for everything on at once. And this is, again, sort of like a flatten phase function where I'm just doing some cosmetics here so that it's a little bit easier to look at this entire phase graph in one place here instead of doing unwrap phase. So now I can see this whole thing here. So over here in Crosslite, before we can start working on this alignment again, remember we have this offset to deal with. So in Crosslite, I don't know how you can change the delay locator value afterwards, but what we can do is instead of putting delay in the sub channel, we can put delay in the main, okay? And that would be sort of like going in the opposite direction. Okay, So this should look more or less like what we were looking at in RumiQ Wizard. So I'm just shifting the display around here to see how we can get this working. So let me just double check that I've got my levels matched. Level. There we go. Let's go back to looking at just the phase. And so we were talking about trying to put in a second order filter. So I'll do that here. And then I can slowly, click down and bring the filter down. So I'll just sort of hold my cursor down and slowly we see them start to approach each other. And there we go. I think this is probably the alignment that we are looking for. Whoops, a little too far. Something like this. So I'm looking all the way through the crossover region here, but also up here as far as we can potentially go. And at the same time, I could be looking at the magnitude, just like I was doing in the time alignment tool in RumiQ Wizard. I can now put my cursor here and I can move these up and down and, watch the black line change and watch, sort of everything move together and see if I like this. Okay, so interestingly, over in Subaligner, we have some similar information. So maybe we want to see if we can get a little bit better alignment than just delay and polarity. So I've got this experimental filter setting here, and you can see that one of the recommendations is a fourth order Butterworth filter at 128 Hertz. So let's finish this second order Butterworth filter first, and then we can make a comparison. So let's say that I'm done sort of playing with this and optimizing these settings. I'll put this at 80 Hertz, and I might increase the range here a little bit just so I can get really picky. Cool. And now I can store this. So I'll go to, and I'll call this second order Butterworth at second order Butterworth. And I can close this memories window for now. And now I want to have a comparison. So let's go back and just use the delay settings that I had before. So let's bypass this filter. And what is my delay preset? 9.97 milliseconds and a polarity inversion. So let's put that in here, 9.97 milliseconds and a polarity inversion. There we go. So this is what we were looking for. And by the way, there's kind of a cool auto solver in Crosslite as well. If we put these cursors at exactly the place where we want to be aligned and we kind of put them on top of each other, then we see what's happening over here, and it says, hey, channel 1, channel 2, between these two cursor positions you have a difference of 7.5 degrees. And I could come down here, right click in this field and choose use delay from some phase delta, which that's what this is, some phase delta. So I click on that and that does the alignment for me. Okay, pretty much the same value we had before. Just wanted to show you that. Okay, so this is my solution if I use delay and polarity. And so now I might want to store this over in memories. So I'll choose memorize current and I'll say 10 milliseconds inverted. Memorize. And that's kind of messy at first, but I just change this to magnitude and I need to hide these other ones again. Okay, and we can immediately see that the one with just delay is giving me more summation through the crossover region, right? But let's continue our investigation. So let's reset these values. And let's clean this up a little bit. Just look at magnitude again. Okay, so let's look at another recommendation from Subaligner. Because, let's go back to phase here. We were talking about like what things we can do, what filters we can insert that will create 90 degrees of phase shift, which is what we need to get this blue trace to sort of bend down and touch this red trace instead of delay. So we know a second order low pass filter would do that. We looked at that. Well, what else might do that? Well, we might use an all pass filter. And that is one of the suggestions that we saw here in Subaligner. So it says you might try an all pass filter, second order, at 100 Hertz with a Q of 2. So let's try that. So over here under filters, I already have this inserted, so I just need to turn off the bypass, and let me do that for you again. So watch this blue trace, and let me show you just the crossover and filters here. So right now it's flat because there's no filters inserted. I insert this filter, and oh, because we only see magnitude. Of course, an all-pass filter doesn't change the magnitude, so let's look at phase. There we go. There's our all-pass filter. If I bypass it, it's flat phase. If I insert it, we see an all-pass filter at 100 Hertz. We see this thing bend down. Now there was another setting here that says delay by 0. So we've saved ourselves 10 milliseconds because this is basically 0, but I can put in 0.03 milliseconds. It's not going to really matter, right? This is super close. So let's just leave that the way it is. Let's look at magnitude and phase. So now I can see my result here, the summation, and let's memorize that as well. So I'll say memorize current, and this is, and let's zoom in. So show cursors. And so now we're going to get really picky because we can. And so now we're looking at these three options that we just made. The worst option is the second order Butterworth filter that I added. The much better option is just with delay, and a slightly better option, you can see green here, I get a little bit more summation out of it, but just a tiny bit more, so it doesn't really matter, I guess. But if I have an all-pass filter available to me, then I could use that instead of delay and get even better results. And the only other thing we didn't try is this fourth order all-pass filter. So I could continue going through and doing experiments. And at this point, this video has gotten pretty long, and if you're still watching, congratulations. But you're probably wondering, like, this seems like a lot of work. Why would I go through all of this? Well, honestly, at this point, it's just because this is fun for me and I enjoy like investigating this stuff. But also I have found that the more I play with this and the more I sort of look at this data in different ways, even if I'm not like doing it right or like finding correct solutions, but if I'm just like playing around with it, getting used to looking at the data, everything goes more smoothly tomorrow because I get into the field and I sort of start to recognize these patterns. You know, it's like speaking a language where you start to hear patterns in sounds, and you don't just hear like individual pieces of words and try to put those together. So it'll speed the whole thing up and make it a lot easier than if I had never looked at this at all. Okay, so I think that's where I'm going to stop this. What I want to do in the next video, though, is look at two speakers from two different brands, because this was kind of easy, right? Like these two speakers are meant to play together. They're both RCF speakers, I think pretty much from the same family. But on this particular show, I also had some fill speakers, some QSE K12s, I think, totally different brand. And I had to make those work with my HDL 20As from RCF. And this is where the power of this really comes in. Because most of the time, if we have two speakers from the same brand, we can just use their prediction software, right? Like, why not? In this case, RCF, I think, doesn't have a solution for this particular speaker. And so that's why this was helpful, but it's going to be extremely helpful when we have two speakers that don't even live in the same like modeling environment together. And so we can do some like quick experimentation to see how that might work together. So that's what I'll do in the next video. If you have any questions for me about this process or any suggestions for me, or you noticed that I did anything wrong, I love hearing about that stuff. I'm always trying to improve my methods. So please comment below this video. Thank you. Sound design. Yeah.